there will be a change along the flow direction, right? There will be but there's no mixing for backward or this part of the fluid mixed with the forward fluid, no. Okay, so the mixing will only be on the lateral direction. So means if you cut, this is the tube, right? If you cut on this surface, there will be well mixing. But before and after, they cannot mix because the fluid can only flow along this one direction. They cannot flow back. Are you all clear? Please, you need to know how to describe this part. Go back to refer to the topic, plug flow reactor, how it works. Then for CSTR, roughly the working is similar to batch reactor, right? The only point will be for CSTR, you will have a feed continuous in and you have a product continuous out. So this part, please take note, for CSTR, there's a very particular point you need to know. At any moment, inside the reactor will be the same as outside. So if you go back to the descriptions of this part, okay? So it means at any moment inside the reactor, the concentration is the same as the outlet. So this is a very important point. But the mixing part, same as batch reactor. Okay? At any moment, anytime, inside, everywhere, the composition temperature will be the same. Okay? Alright, please, this type of question, don't try to write long stories. Try to get the key point. Just answer the key point will do. Okay? Can? Any questions here? No, Can we move on? Okay, then for topic 4, we have introduced a new concept here, space-time and space velocity. Okay, please take note. We will not give you the formula for space-time and space velocity. You memorize, Space-time is the reactor volume over volumetric flow rate. But if you don't have the volumetric flow rate directly, you have concentration, you have molar flow rate also can. So please memorize this. Yes, you can see there are some there. Try to find a place to sit down. It's good, at least you are here. You will hear the very important points, please. Okay? So the units for space-time will be either minute, second, or hour. Okay, listen. You need to explain what it means by space-time. You go back to the topic 4 lecture notes. Listen, you go back to your topic 4 lecture notes. There is an example, ask you to calculate the space-time. After that, you need to explain what it means. What does it mean? Anyone can tell me? You should know very well now. What does it mean? The time needed to treat one reactor volume of fluid is a space-time. Remember? The time needed to treat one reactor volume of fluid is called space-time, right? Then you can say, this is the definition of space-time. Then you write this formula. Okay? Then what does it mean by space velocity? The number of reactors can be treated per minute or per second or per hour. So it means unit time. The number of reactors can be treated in unit time. Okay? This part you don't need to memorize. remember velocity is 1 over tau. That's it. So this one is from 1 over tau. You don't need to memorize this. Okay? Let's move on. So this is the first important concept. Then come to the calculation part. You please focus on whatever I mentioned here. Okay? Alright, so we will give you this design equation. You start from here. Okay? So this design equation will be given. You start from here. Please remember these few steps. Step 1, rewrite. Okay? Step 2, multiply a CAO at each side. See, after you multiply a CAO, this is tau already, right? This side is already tau. Then this side is CAO minus CA. Then below here is the reaction rate. So these few steps, 1, 2, 3 only. Then after this, please substitute the first order, second order, or any other order equations into here. Usually the question will ask you to find either reactor volume or space-time. Okay? So after this step, please come over here. The table I give you. Can you take out the table I give you? That one's still very important. Okay, we come over here. So this table, now you can ignore the batch reactor. Why? Because batch reactor, no matter you follow this way or you follow what you learned in topic 3, the integral method, right? Anyway, you will need to integrate from here to find the final for first order, then final for second order, like this. Okay? This part you still need to know for batch reactor, because this is the same as what we derived in topic 3. So you follow that will do. Okay? And then for here, please take note, just now I said you come over here already, right? Okay, what you need to do is from here onwards, please substitute the read equation. For example, now it's first order, so it should be KCA. And then for second order will be KCA squared. Okay? Either use this or use the conversion. Why the conversion become like this? Anyone can answer? Why? No matter it's by conversion or by the concentration, you should know well. Okay, so we are here now.
Damn nice.
Right.
I went from like that to this.
Okay. Then for first
I
order,
was supposed to finish on Monday, but then like I kept on dragging. And then someone today I finished
if
it.
let's say the KCA, right? Okay. So CAA actually, if let's say the question asks you to just give you a conversion, you don't have the concentration, doesn't matter. So you write back into that. Okay. So after this, you see this one will be cancelled. So finally, you will have here. See here, if you don't have concentration, you have a conversion, also can. Okay? Are you clear on how to derive this? Can So this is for CSTR first order by conversion will be this. Then the second order will be here. the same, no difference. You just need to substitute the KCA squared inside, that's it. But normally, please, for second order, you follow this way. We don't ask you to do for conversion. Conversion is too complicated. Okay? You just do this, we'll do. So this is for CSTR. Actually, if you see CSTR, we can give you any order. Can be first order, can be second order, can be other order. You just write in here. That's it. So for example, if I give you a 2.5, you just write a 2.5 here, right? Okay? So for CSTR, I hope everybody you should do well. If you see a CSTR, right? Okay? Now, let's see how to do the plug flow. So this is for CSTR, right? After this, you go back to the table, you continue for first order, second order, or any other orders. Then for plug flow, we also start from here. We will give you this. We will not ask you to derive this. Okay, we will give you this equation. So the same, you rewrite dV over FAO, then similar to this, you multiply a CAO, then you try to replace dXA by dCA, finally you will have this. Okay? This one will not be given. I know every year some of you just go by shortcut, then you memorize this equation, you come over directly. Also can, but you will lose a few marks. If you are not confident, actually you write 1, 2, 3, maybe 3 steps, you come over here already. Okay? Okay? So after this, right, then you need to go to the table again. To do first order, to do second order. Okay? So please, for plug flow, the most important is first order and second order. Okay? So we come over here. Starting from here, you come over to the table again. It's here. Alright? So now we are here. Anyway, please don't use dXA directly. This, for the integration by dXA, if your order is second order, it's not easy to do. So we try to use this, dCA. For dCA, this one anyway, you are very familiar already on how to do. Just repeat one more time. Make sure everybody knows how to do this. How equals to minus. Now if it's first order, KCA, right? Okay, K is constant. So just the minus is still here. Just take out the K, then you will have a dCA, CA integration, right? Okay. So minus 1 over K. Then inside, you'll have ln CA minus ln CAO. Okay, don't forget outside you have a minus, right? So it will be 1 over K ln CAO over. If you write by conversion, one more step. Okay, so this will be cancelled. Okay, so this is for first order. This is on how that two equations is derived here. This part and this part. Okay? So this is for first order plug flow. Any questions? You should know, please, everybody, you go back home and practice. Then second order. So I directly write this way, dCA This part is the same as batch reactor. No matter second order, third order, or whatever other orders, you follow, you write one more step. If you are not very confident directly to do that, write one more step. This is -2, then DCA. Okay? Always write the limit. Then here, how to do? -2 plus 1. Please, this integration you have to memorize. So only the first order is special. The integration is long something. Then other orders will be same. Okay, so inside here you have the CA -2 plus 1 minus CAO minus 2 plus 1. Okay, so finally you will have 1 over K. Inside is okay. Any questions? So you see what we have for second order is here. So this is what we derived. Okay. Then one more thing for everybody you should know well is CA equals to CAO 1 minus XA. This one you have to memorize. Okay. So means if you know the conversion, how to find the final concentration from this. Okay? Okay? So this is how to derive. Okay? Then the last part of topic 4 will be on how to use the graph. Okay? How to use the graph, please, both first order, second order are important. If the question needs you to use for second order, we will give you the second order graph. If need you to use the first order graph, we will give you the first order graph. Okay? Just take note, the first order and second order on the graph, the dotted lines are, okay, for first order refers to K tau. For second order refers to KCAO tau. Okay? Then you need to know how to read. Let me see, I have the graph behind. Not here. Okay? So please, this part will be tested. The graph method, yes, will be tested. Okay? You need to know how to read. If this part you are not confident, I just show you one. You go back to study your tutorial. It's our last week tutorial, right? Okay, so this tutorial is on how to read from the graph. Okay, so this question already covered both first order and second order. You see, first question say this is the first order, right? Then you need to find out what is the K tau value, which equals to 2. Okay, then take your reading, and you have 2 CST. If one CSTR change to plug flow, it means K tau doesn't change. Okay, then you go to the other line. But for this question, originally it's plug flow, right? And change to CSTR. Then please remember, no matter first order or second order, when you read the graph, listen, if you have 2 identical CSTRs, this K tau must be doubled when you read from the graph. Okay, now, okay? So this is for question 1, this is the first order, right? Then for question 2, it's mentioned you repeat the question if it is a second order. So you see, for second order, you have to calculate K tau CaO. Then from there, you take your reading. Okay? Can you all please practice this tutorial? This part will be covered up in your final exam. Okay? So this is for topic 4. Okay, one more thing. For the y-axis of the graph, originally it's written as tau of CSTR over tau plug flow, right? You should know this one is actually the volume ratio because other parameters will be constant. It's not written so clearly on the graph. Okay? So you need to know the y-axis actually is the volume ratio. Are you okay? Hannah? So that's it for topic 4. Okay? So topic 5. Okay, topic 5, the first part. Please, you need to know the difference between process design and mechanical design. Okay? Process design is mainly design based on the process-related parameters, right? So you go back to your notes and check what are the main parameters. And then for mechanical design, it's mainly about the equipment structure itself, like for example, stirrer, impeller, or what kind of materials. Okay? So matters for consideration in process design, please try to list down at least 5 points. At least. We have 10 points, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what are the things you need to consider as a process design? Okay? Okay? Then for the key point for topic 5, other than this, will be mainly the design of reactors, right? So will be connections of 2 reactors either in series or in parallel. Okay? So if in series can be first order or can be second order, right? So this part, just now I mentioned already. If you have a single CSTR, it's like what we are doing in topic 4, right? Okay? So you just need to come over here, then you will know how to show your final concentration, relate your final concentration to the initial concentration by this. Then after this, do you need to memorize this? I never encourage you to memorize this, but come back to memorize this is more important. Okay? So if you know this, you should know what is the meaning of conversion. Conversion means CaO minus Ca over CaO. This is the definition of conversion. Everybody you should know. Okay? No matter how we write. So this is the original definition. Okay? Alright. So this is for single reactor, right? If it's first order. But if you have 2 connected, you should know how to write accordingly. Okay? Actually, if you are able to write first one, please for the second one, you just need to, you see, you just need to change your outlet will be Ca2. Your inlet will be Ca1, right? Then after that, your Ca1 is here, you sub this into here, you will have this final. If let's say the question mentioned you have 2 identical, means these 2 exactly the same, then you can combine the below one into this. But if it's not the same, doesn't matter, you just follow this one. Okay? Okay? So if it's not the same, you remember I give you this already, right? Okay? You follow this way. Either it's identical or not identical, you follow this way, you can do all. Okay? So you see here, in this question, I mentioned V1 equals to V2 equals to V. If they don't equal to each other, also doesn't matter. You just do one by one. You do the first reactor first. Okay? So you do the first reactor by this. Then you do the second reactor. If they are identical, then you can combine into this. Then after you calculate this, right, please go back to the definition to find your final overall conversion. So overall conversion for this case will be Ca2. So means from the exit of your second reactor, after first, after second, what will be your overall conversion? Okay? So never memorize that equation for the conversion. No need. You just calculate in this way. After you find the concentration, you come over here to do your calculations of conversion. Okay? Okay? Is it alright? So this case is for identical case, right? Okay. See, don't memorize this. No need the conversion part. Okay, so this is for the two CSTRs connected in series, right? Then if they are connected in parallel, for parallel, we only need you all to know this case. Okay, the volumetric flow rate will be equally distributed into the two reactors. So means the volumetric flow rate will be half of your original. This is the only point. Then the two reactors, whether the volume is the same or different or cut half, you need to read the question carefully. Just like your tutorial question, the two reactors are cut half, right? Okay? So you just change the volume accordingly. Then you just do one by one. It's like you are doing a single CSTR here. Then you do another single CSTR here. Okay? Okay? So this is for parallel. If let's say the reaction is a second order. Just now it's for first order, right? For second order, same. Okay? So you just need to do for single CSTR, just now I showed you already, right? How to get here. Then you just need to substitute KCA1 for the first reactor. For second reactor is CA1 minus CA2. Then this is CA2. Okay? So this one also follow this way. You have one tutorial question on this. Okay, I will not give you 3 reactors lah. To be very frank, I will give you 2 only. Okay? Okay, take note. So if you have 2 only, I will cover this part. You just need to do the first one. Okay? It's just like you are doing a single CSTR for first one, right? Okay? Then you find the outlet concentration Ca1. Then you follow this definition to find the conversion. Then you do the second one. Okay? You remember in your tutorial questions you have 3 CSTRs. The first one is 5 liter, second one 10 liter, the other one is another volume, right? So can be different volume. But please take note. This part you need to know. Tau equals to V over V naught. V and V naught in the question will be given to you already. So means you are able to know the tau directly. So inside here, only the Ca1 is unknown. Some of you may have mathematical difficulty. If you have that, you have to practice a bit. So it's something like you find your tau 1 from this V1 over V0 already, right? Okay, after that, you can write tau 1 equals to CAO minus CA1. And here is K CA1 squared. Okay? Now after this, we write K tau 1 times CA1 squared equals to CAO minus CA1, right? Now after that, rewrite one more step. Okay, so this is something like your ax squared plus bx plus c equals 8. Right? You should know how to solve this, right? It seems your calculator got the function to do this. All of you know, directly you can get your answer already, right? Good. Then previously the calculator don't have this function. You have to write all the formula, mathematical formula to do it. Anyway, so if you know this, you should be able to find CA1. Correct? So you do the same thing. Please, for the second reactor, you do the same thing. You find CA1 already, right? Okay, so you repeat one more time. That's it. Okay, then is there a possibility? Okay, you see, so you have one. Different volume, so this is B1, B2. CSTR. Okay, so you just do this first, then you do this, right? You find your answer. Okay? Now if I say you replace this by a plug flow, are you able to do it? How to do it? Say here. So this is still your V1, right? Then you change to a plug flow. So means this is your CA0, this is your CA1, this is your CA2. So means for this one it's still a CSTR. You just do it according to this, right? Okay? Then after you find the concentration for the second reactor, you just follow what we derived just now from plug flow. That's it. This is the plug flow. So for the plug flow, what is the difference? Only the limit now changed to CA1 to CA2. That's it. Okay? So we may ask you in this way. Originally you have two CSTRs, you solve it. Then we say you replace the second CSTR by a plug flow. Don't be so scared. You just do for the plug flow separately. That's it. Okay? But you just need to change the concentration in this way. Are you okay? Okay? Don't forget, topic 5 is regarding reactor design. So can be 2 in series, can be 2 in parallel, can be 2 identical CSTR, first order or second order. Then we can say you replace one CSTR by a plug flow. So even you replace, don't be so scared. Just like you are doing an individual CSTR or plug flow. You just do separately. Okay? Okay, so this is topic 5. That's it. Lastly, topic 6. Topic 6 is a very short one. I just list down some questions here. If you can answer, will do. And also, I will post the last tutorial answers in LMS. You just follow that. These are the key points. So for topic 6, don't have any calculations. No derivations, no calculations. So only some kind of simple questions like this. If you can answer, will do. Okay? Is it good enough? Can okay? So that's it for topic 4, 5, and 6. Yes. Yeah, it's like, let me see. Okay, you see your. It's something like this lah. This is your tutorial 12. This is the last tutorial. You can see what is the property of the catalyst. differentiate between homogeneous and heterogeneous, right? Then the difference between these two mechanisms. Remember these 7 steps, very important. Okay, please memorize all these 7 steps of the mechanism. How the gas is absorbed onto the surface. This one is inside your notes already. Then after that, so this one is for your reference. I will not test you this. This last question is a calculation plotting of a straight line. Then from here you can find the total concentration. I will not test you this. Okay, good enough? Yeah. This calculation will not be tested. Okay, so you just focus for topic 6. If you can answer all these questions, will be okay already. Okay? Alright, so tomorrow's lecture, I will go through past year's paper. Our last year's paper, I already posted here, past 2 years, with the solutions as well. Okay? I will go through last year's. Okay? Study with the revision is mainly for those very weak students. Even after this, you still cannot follow, you come. Okay? Okay, I think after this, everybody should be okay already. No need to go through so many revisions. No need. Okay? Please focus on what I mentioned today. Okay? Good enough. Study hard. Okay, regarding the examination venue, there may be changes. You wait for further notice. You check your personal timetable. Because of this virus issue, it's not encouraged to have many people at the same place at the same time. They may split into smaller places. I don't know. You just wait for further notice. Okay? Also, please take care of yourself. Wash your hands frequently. But I see here the instructions is if you are not sick, no need to wear mask. You just follow the instructions. If you got fever, you are not comfortable, don't come.